Justin Herbert faced one of the defining pressure problems of the 2025 season. NFL Pro labeled 255 of his 619 dropbacks as pressured. PFF, using a different definition, counted 263 pressured dropbacks out of 616. That is not 8 mistakes waiting to be corrected. It is 2 providers drawing the boundary differently, and both land in almost the same place. Herbert was pressured on roughly 42% of his dropbacks. The important question is not which number wins. It is what the combined evidence can actually tell us about where that pressure problem came from. To answer that responsibly, we have to separate 5 layers that football arguments usually collapse into one. Provider tracking tells us which dropbacks belong in a pressure group. Play-by-play tells us what happened on those plays. Timing describes Herbert's behavior before throws and sacks. PFF blocker assignments describe where individual protection losses were charged. Responsibility asks who caused what. The first 4 layers are informative. The 5th is incomplete. So this is a descriptive account of the strongest evidence, not a formula that assigns every pressure to the line, the quarterback, the scheme, or the defense. Start with exposure. In the exact NFL Pro cohort, 255 of 619 Herbert dropbacks were labeled pressured, or 41.2%. PFF's separate cohort produced 263 of 616, or 42.7%. We will not merge those counts, because their definitions were not reconciled play by play, but their directional agreement matters. 2 separate provider views say the Chargers' passing game operated under extraordinary pressure exposure. That establishes the size of the environment. It does not, by itself, identify the culprit. The outcome split was enormous. On the NFL Pro labeled plays joined to play-by-play, pressured dropbacks averaged -0.374 expected points added. Clean dropbacks averaged +0.356. The raw gap was -0.729 EPA per dropback. After a frozen adjustment for observed pre-snap context, pressure remained associated with 0.767 lower EPA per dropback, with the whole game bootstrap interval from -1.041 to -0.536. That is not a causal estimate. It adjusts only for variables we observed. And because sacks are both a pressure outcome and a major EPA penalty, we ran a sensitivity without them. Across 565 non-sack plays, the adjusted association remained -0.470. Pressure was not merely a synonym for the sack penalty. Public play-by-play is also a poor substitute for provider-defined pressure. A simple hit or sack flag captured only 119 of the 255 NFL Pro pressure events. That is 46.7% recall, although precision was 92.2%. The other 136 provider-labeled pressures would disappear from a study using only that public proxy. Even within those proxy missed pressures, the adjusted association versus clean plays was -0.313 across 500 plays. So the larger pressure map adds real information, while still leaving responsibility unresolved. Now take the strongest version of the case against Herbert. His PFF time to throw was 2.93 seconds, modestly longer than the qualified quarterback median of 2.86. His pressure to sack rate was 20.5%, versus a 17.9% median. He did hold the ball a little longer than typical, and he converted pressure into sacks somewhat more often. But PFF's own responsibility field sharply limits the claim. On 236 offense-attributed pressure dropbacks, PFF assigned 40 to Herbert, 16.9%, almost identical to the 16.7% qualified median. That denominator is PFF's 236 offense-attributed pressure dropbacks. It is not NFL Pro's 255 pressure events. The evidence supports a smaller elevated sack conversion component. It does not support saying Herbert created most of the exposure. The sack clocks add another warning. PFF measured Herbert's average time to sack at 3.52 seconds. Shorter than the qualified median of 3.71. A separate public next-gen stats map measured a 4.684-second mean and a 4.612-second median across his 54 sacks. In that NGS map, 44 sacks lasted at least 4 seconds, and none arrived under 2.5. Those values are not contradictory, because PFF and NGS use different timing clocks and source contracts. They cannot be averaged together. More importantly, sack duration is not a blame label. A long sack can include early displacement, an escape, covered routes, or a missed outlet. A shorter sack can involve a protection loss, a free rusher, a quarterback decision, or several things at once. The line evidence is material, but it is not uniform. PFF charged Joe Alt with 7 pressures on 184 pass block snaps, a 3.80% rate, and only 1 on 76 true pass sets. Zion Johnson's 26 on 632 was 4.11%, better than the 5.45% guard median. Other spots were much weaker. Mekhi Becton's 37 on 426 was 8.69%. Austin Deculus allowed 37 on 325, or 11.38%, and Trey Pipkins allowed 27 on 352, or 7.67%. Both were worse than the 6.30% tackle median. Bradley Bosman's 30 on 623 was 4.82%, worse than the 3.31% center median. Trevor Penning and Foster Sarell were weaker in smaller samples. PFF recorded 270 blocker pressure assignments, but shared assignments mean that is not 270 unique pressure plays. The fair conclusion is align with strong pieces, material weak links, and changing personnel, not one uniform grade. At the weekly level, complete line assignment rate correlated positive 0.648 with NFL Pro pressure rate across 16 games. That is a useful descriptive alignment, not a causal estimate, and the small sample matters. It says weeks with more blocker assignments tended to be weeks with more provider-labeled pressure. It does not tell us how to divide any individual play among the linemen, Herbert, the call, the route structure, and the defense. 3 late-season weeks make those limits concrete. Week 14 was a joint breakdown, a 61.0% pressure rate, 26 blocker assignments on 205 pass block snaps, 7 sacks, and negative 0.474 EPA per pressured dropback. Week 15 cut the line assignment rate to 3.59%, yet Herbert was still pressured on 44.1% of his dropbacks and took 4 sacks. That is a residual the line table alone cannot explain. Then week 16 produced the opposite diagnostic, a 39.4% pressure rate and a 7.23% line assignment rate, but 0 sacks. Pressured plays averaged positive 0.849 EPA, higher than the positive 0.726 clean average. The only week when pressure beat clean in this split. That exception demonstrates compensation and week-to-week variance. It does not make season-long pressure beneficial. Herbert also created substantial value after structure broke. PFF counted 49 scrambles for 439 yards. In a separate all-rush measure, Next Gen Stats credited him with plus 128 rushing yards over expected and plus 25.9 rushing EPA across 83 rushes. Those definitions stay separate. PFF's figure is scrambles, while the NGS values cover all rushes. Together they show that Herbert's response sometimes rescued offense from the pressure environment. They do not erase the exposure that forced so many responses in the first place. The leading descriptive account has 4 parts. First, the exposure was extreme. 2 providers separately put it near 42%. Second, offensive line weakness was material but non-uniform, with excellent performance at some spots and severe pressure rates at others. Third, Herbert generated meaningful compensation, especially as a runner. Fourth, his pressure-to-sack rate was elevated, so quarterback conversion belongs in the story as a smaller component. None of those findings supplies an exact blame share. Anyone reducing the season to one culprit is claiming more precision than these data contain. The responsible ending is therefore unresolved responsibility, not a roster prescription. NFL Pro defines the exact pressure cohort used for the outcome study. PFF provides a separate exposure count, timing comparisons, blocker assignments, and its own quarterback responsibility field. Public Next Gen Stats provides a separate sack clock and rushing value measures. Play-by-play supplies outcomes. The sources agree that the problem was large and that pressure carried a major observed cost. They narrow the plausible explanations. They do not identify the protection call, route, chip, first rusher, escape opportunity, and quarterback decision on every play. Herbert's pressure problem was bigger than one culprit, and the evidence is strongest when we stop pretending otherwise.